Hey everybody, my name is Austin Story, and I am a tech lead and manager at Doximity. I'm honored to be here to be sharing lessons that Doximity, our team, has learned over the last several years of how to effectively sync data between Rails microservices and do that at scale. And I'd like to start with painting you more of a picture of what we're going to be talking about over the next half hour. And that's going to be whenever you have a company that has more complex data requirements. And whenever you start, things are a little more simple. It's easy to make decisions. You have a Rails monolith following the Rails way. How do you keep your application developers and your data engineers in sync so that you can lean into all of the rich things that Rails provides for you in order to keep your rich domain models in sync? Over time, as your business grows, your data needs grow, your applications grow, get more lines of businesses, you end up in a situation where you have multiple apps, multiple teams, multiple data teams, multiple application teams, and those problems become harder and harder to keep the data team and the web application team in sync. And then finally, imagine that you're in a situation where you have dozens of lines of business and you have 70 plus application developers, dozens of teams that are working on and relying on Rails to provide rich data needs for your clients, and then data teams where you have 45 plus data engineers and over a dozen teams. That's what I'm going to be talking to you about today. How Doximity has solved that problem to effectively sync the data between multiple Rails microservices and enable our data teams and our web application teams to work together. The way that I'm going to do that is first I'm going to start talking a little bit about the background, talk about the domain, a little bit about Doximity, our company, and then we're going to talk and we're going to define explicitly what we mean when we say effective data syncing. After that, we'll move into more of the application and company growth that we experienced and some of the things that we tried along the way to keep our data team and our web application team in sync. And finally, we'll end up on what I call our secret sauce, the architecture that has worked for us over the last several years and has enabled billions of effective data syncs in our system. Now, a little bit of background and domain. Now, first, our company is called Doximity. It is a 11-year-old Rails-based application, and our company is focused on it's a professional network, professional medical network that is focused on enabling physicians to save time so that they can provide better care to patients. We provide doctors with a lot of ways to communicate in a more modern way to enable their workflows, and also some continuing education tools for them. And some of the products that we've developed over the years in order to enable that are like Doximity Dialer. That is a product that has facilitated over 100 million telehealth calls in the US. And then another one that I'll be talking about a little bit later is called Continuing Medical Education. That is an entire system where we ingest articles that are medically relevant and we give them to doctors so that they can read them and get credit for that for their continuing medical education. We have rich search that is enabled through our integration with Rails domain modeling. We have secure faxing and messaging. We also have rich profile data for our physicians. You know, they have simple things like name, but also things like their specialty, the things that they've done, and where they've went to college, university, those sorts of things. And another important area is medically relevant news. We provide that for our teams and our physicians in the form of a newsfeed. And in order to, and because of all of those features that we've had, we've grown to a point where we have over 70% of all the US physicians and 45% of nurse practitioners and physician assistants as verified members on our site. Now, with that amount of features and users, we have to have a lot of teams in order to build that out. At this point, we have over 10 data teams with 45 plus engineers and 20 plus application teams with over 70 engineers that are building out and maintaining these features. And the system that I'm going to introduce you a little bit later, our data update tool, we've performed over 7.7 billion data updates since April of 2019. So now that we know a little bit of the background, the domain that we're going to be talking about, Let's define effective data syncing. What I'm talking about here is data integration in Rails. So you have many Rails based microservices, and you have many different data stores. How do we move data to and from those different data sources while respecting application business logic without breaking things? Now, before we go into the talk about application growth, I just want to give like a preview of the solution that we ended up on. In general, it is a Kafka-based system that allows our data team to produce messages and our application developers to consume those messages that they're produced. They're able to work independently because of that. Now, in the beginning, before we had all the teams, all of the microservices, we had the monolith. And our monolith was quite majestic, sparkly, had unicorns, and it had sprouted wings at some point. And just to give a summary of how data updates work in a monolith application, I'd like to kind of step through that. This is the way whenever you have a monolith, you're trying to get data updates in. But at the end of the day, all that we really care about is that we're able to serve our users. For us, it's physicians. They don't care about all the stuff that we're doing. All that they care about is that they're able to get the stuff that they need and access the data that they want whenever they want it. But Rails is so fantastic at providing a rich way to model all of the domain logic that exists and is distributed amongst many data stores, MySQL, Redis. And there's also a lot of Rails developers that are very familiar with all of the primitives that Rails provides, all the abstractions in order to integrate or in order to communicate with those data sources. And whenever you have a data need, something that is more simple, say you want to go in and upcase all the physicians' first names. Business talks to the Rails developers, and the Rails developers have a very well-known, mature set of tools in order to handle that. Cron, Rake, Active Job, Rails Console, in order to get those data updates to go through the rich domain modeling that Rails has provided and sync it to all of the data stores. And just as a way to demonstrate how fantastic Rails is at keeping these data stores in sync, I'd like to talk about what you would do if you wanted to add better search for your users. And say you want to enable your physicians to be able to find each other by many other types of criteria. So name, where they went to university, and you want to be able to sort that by relevance and control scoring and that sort of stuff. So your team decides to use Elasticsearch for that because it's very good at that sort of stuff. How do you keep your Elasticsearch system up to date with your users? Now, there's a lot of ways that you can approach this problem, but I think that this is one of the areas where Rails shines with its rich application domain modeling. Now, there's a lot involved with doing search effectively, but whenever I'm focusing on just the step of making sure that your user data stays in sync whenever you change it with your Elasticsearch index, all that you really have to do to accomplish that is create an after commit hook in your user model to schedule a background Elasticsearch sync, and then have that method kick off a background job that will successfully re-index the user in your Elasticsearch. This is one of my favorite parts of Rails. It makes tasks like this so simple and straightforward. And it's also one of the reasons why over time you get a ton of very rich domain logic in your Rails models. Now let's talk a little bit about what happens whenever your business gets to a point where it needs more data, like more experience data. And here's some examples of reasons that that would happen. So Doximity is a very data-driven company. Most of the decisions that we make for new products, leaning into specific areas of our business, are related to the feedback that we're getting from our users on whether they're engaging with our specific products. So there's a very sophisticated analytics pipeline, and we need to know how what we're doing is working in a timely manner. Doing that is very difficult. It requires people that have deep specialized knowledge in data pipelines and analytics. Then there's also some other features that we lean on quite heavily, like machine learning, recommendations, and data pipelines. But let's look at a real example of a complex data need that we've actually built out so that we're talking in concretes. So earlier I mentioned that we have a lot of physician profile data. These are things like usernames, where people, or not usernames, but first name, last name, where they went to university at, their specialty, their subspecialty. And then we also have that continuing medical education that I talked about, where we ingest articles and we're able to put them through um, a pipeline where we can extract out things like who has been cited in other articles. So business gets this idea, hey, how empowering would it be for our physicians if they were able to see that when they created a white paper or a journal somewhere, that somebody else cited their work in the other person's article. And the end result that we had was, this is something that we've released and physicians like it. It's empowering. It's cool whenever people do work and other people rely on that. And it allows the physicians to do things like, you know, one, feel better about writing articles and write more articles, more journal entries, or go in and double check that everything, is gelling with what they were saying. Now, doing this is a subtly complex problem. There is a lot involved with matching CME article citations with physicians' data. The first part of this is you have to make sure that all the physician names are correct. How do you do that in the first place? And then after that, you have to make sure that you have the information there on the physicians, like what is their specialty, where did they go to university. Uh, then for the CME articles, you have to clean and standardize all of the citation names that appear in these journal entries. That's also hard because there is no standard format for this. A journal could choose to do first name, last name, first name. They could put any string of characters that they want in there. And then after you're able to get all the physician data good and standardize all the citing names, which are both hard processes by themselves, then I think the real difficulty starts where you get into name matching. You know, for common names, like Austin Story, that may not be too difficult. But what if you have a very common name and you have multiple physicians that share the exact same name? Then you start getting into confidence scores where you look at the person's specialty. Is this a journal entry related to a specialty that they would be writing in? Is this related to something that they've done in the past? So this is very, very difficult, and our data team does an incredible job at it. But it does require deep expertise and specialists. So how do we integrate these data specialists that have their own unique sets of tools that they need into our existing Rails monolith application so that the things that they're doing get piped through our rich domain models? Because they're used to things like Python, Spark jobs, raw SQL. How do we do this? Well, I'll tell you about the steps that we took in order to accomplish this. And the first one is a question that I ask a lot is, what is the easiest way to do this? And one of the easiest ways that you could arrive at is to just give them direct database access and then promise to be super careful. But before you just walk away from that promise, you have to solidify that with one of the most binding contracts possible, which is the pinky promise. Now, after you've made a pinky promise to be super careful whenever they have direct database access, there's a lot of pros and cons that you can evaluate with the system. Uh, the pro is that it's very easy to integrate them in the system. You don't have to make any changes to anything that is over in your rich or in your Rails ecosystem. You just give them direct database access. But that does come with a lot of cons. The first of which is that pinky promises are actually pretty hard to keep. You know, Even if everybody has the best intentions, what if the context of that pinky promise changes and not everybody on the team gets the update that the context has changed? What if there's some tables that, for some reason, need to be highly available and you can't change them during certain hours? What if there's accidents? And even if there's no accidents and that pinky promise is completely managed correctly, you can't control the load here. The data team can just go in and do whatever they want whenever they want to. You have to coordinate the load there so that they're not overwhelming specific tables whenever you need to serve those to the physicians. And then I think the biggest reason that I don't like this as the way that we do things is because even if all of that happens perfectly, you keep your peaking promise, the load doesn't ever bring down the site because the database servers get overwhelmed. The biggest thing here is that the application, your rich domain logic from Rails, is not going to be respected. Whenever the data team goes in and does that update on all of the users' first names, there's no way for them to run all of the rich domain modeling that Rails is providing you. You don't get the after commit whenever you're doing a direct update in the database. So your Elasticsearch job isn't kicked off. Also, caching. Even if your database team knows, like, okay, whenever I update a record, I need to also update the updated at to now. Whenever I do that, what about the other models that are dependent on touching? Like there's no way that you can expect the data team to be aware of all of the other concerns that could be added in the future. If you need to touch your account whenever you update the user, data team has no way to know that that needs to happen. So the application logic not being respected, I think, is the biggest reason why this one isn't a reason that we went with it. So the next way is I think the next most easy thing, which is just an admin UI with some REST over it. So instead of giving them direct database access, you provide some API so that they can do their updates, submit them through some RESTful call, and then all of your updates do get piped through those rich domain models at that point. So that is much better. There's also some other good benefits here. REST is well known, and it can also be shared with other clients like web, mobile APIs. But there are also some downsides for this, and also the reasons that we didn't continue down this path. The first one is that uh, the limiting of the clients is completely dependent on them respecting when they get a message to stop sending requests. You can't control that. The clients are just fully like they just keep pushing stuff up, and you just keep responding with back off and make requests later. Also, batch processing is difficult here. Most of the time, whenever you're doing batch processing, there's different subtle needs for each type of process that you're going to be pushing it through. And what we ended up with was a lot of snowflake type setups where each type of update was different and each batch processing update was different. So we didn't stick with this long term, but we landed up on what I'm going to call temp tables plus sync. Internally, we call this our data update tool, volume one. And with this type of setup, instead of the direct database access or the REST UIs, you create some temp tables. Data team populates those temp tables, and then you create a tool so that whenever the database team wants to, they can sync those tables to the real Rails application tables. And we ran with this one for a while, several years. The pros on this were pretty high. We had no direct access to the main database, so we didn't have to worry about them accidentally taking down the main database. We were able to separate the data writing from the consuming, which is fantastic. Uh, but there were also some cons here. It was hard to manage the load here, and our batch processing was pretty difficult using the batch processing system that we were using. So this worked. Probably could have worked forever for us, but right as we got this temp tables plus sync solution running, the size of our team started growing a lot, and we started bringing up a lot more line of business applications. And that's what I'm going to talk about right now. So we had a lot of growth about this time. So we had our main application, which had the setup that I just talked to you about, where we had Rails developers and data team working in harmony through this temp table. And then we also brought up our newsfeed about the same time. This is where we're delivering all the medically relevant news that I was talking about. We brought up another service to handle all of our colleaguing in order to facilitate connections between people in our network. How do we manage this sort of setup so that each team is not having to maintain their own way for their data team to integrate with the Rails application? Because keep in mind, at the end of the day, physicians don't care about the way that our backend is set up. All that they care about is that they're able to get the data that they need, and that's what we should be focused on. Enabling the teams to work so that the physicians can get what they need, so that their jobs are easier. Cool. So now we're going to move on to the architecture that works, our secret sauce here. Just to tie this back again to our definition, effective data seeking. How do we move around data to and from the different sources while respecting the application business logic and not breaking things? Now let's talk about how we do this. So we just went through a lot of growth. We had the temp tables plus sync solution going, and that gave us an opportunity to kind of pump the brakes a little bit and say, hey, you know, what we have here is good, but how do we build this in a way where it is scalable, where it is going to grow completely with with our team as we get more teams and more microservices? So we were able to sit down and define a vision, set some goals, some requirements for what we wanted our system to work with or look like for our data updates. And the first thing was that it has to work with our existing code base. Like just completely stopping developing for 6 months or a year is absolutely not an option. So it has to work with what we're doing right now. It also has to be easy to use for the data team. That was some of the feedback that we got from the data update tool. It was an extra step, is a little bit more complex for them to go in and update things. Has to support multiple apps out of the box. So it has to be easy for us to bring a new application into the system. Safeguards to avoid disaster. If the data team is producing too much data, we need an easy way for that to not be impacting our web application servers that are running all of those updates through the rich application domain models. It has to be bulk processing by default. We wanted this to be a first class concern in our system. And we also wanted a complete split between the people that are producing data and the people that are consuming data, completely independent. And in order to fulfill a lot of those needs, we ended up reaching for a tool called Kafka. And I'll talk a little bit about it. It's not the most important part of this, but just know that it's a tool that we used in order to fulfill these needs. So Kafka, the things that it fulfilled for us are it allowed us to split the producers and consumers apart. It kind of acted as like a bridge in between those. It gave us multiple app support easily, and it also gives us safeguards because the data team or the producers of the data are completely independent from the consumers of that data. So they're able to be independent. They were also able to go at their own speed. The producers could produce as fast as they want to. The consumers could consume as slow or as fast as they want to. And there was now no longer a need to communicate between them. You didn't have to go reach out to the application team before a data team was doing a big push. And what we added was an app topic for each of these applications in order to allow them to communicate on just their bandwidth. So, like you have the main topic, you have a newsfeed topic, you have a colleagues topic. And for those of you that are not familiar with Kafka at all, I'll just do like a really high level overview. The easiest way to think about it is imagine that you have a way to send a message to somebody and do it in a JSON payload. It's not restricted to JSON, but that's how we use it internally. And you're able to put it on a text file, and you just keep appending to that text file. And Kafka provides all of the abstractions that you need so that you can distribute this text file and you can consume this from this text file in a way that is very fault tolerant and resilient. And the producers produce to this file, and then a consumer basically just gets like a pointer to the text file, and they just start reading, and then they can stop and start as much as they want to. So another way to think of it, if you're familiar with active support concerns or active support notifications, you are able to dispatch using active support notification, and it's just persisted somewhere, and you can read chronologically through all of those notifications at your leisure. Cool. So how did this look for our system? We have data team split on the left and our data team on the left and our application team on the right. We wedge Kafka right in between those two. And the way that it works is the data team is going to produce into a Kafka topic, and our application team is going to consume from that topic. Now, before we go into a little bit more details about how the data team produces and how the application team consumes, I want to talk about a couple of primitives that are kind of core to our system. And the first is called an operation. Keep in mind, we've done 7.7 billion of these at this point. Um, and it's composed of a few parts. First, it is a command to change the data in some way. And these are the normal things that you would expect, create, read, or create, insert, update, delete, upsert. They're also self-contained. An operation has to be able to live completely on its own. It has everything that it needs so that when the operation is consumed somewhere, the consumer can do everything that it needs to with it. And it must belong to a batch, even if it is a batch of one. This is how we make sure that batching is a first class concern. And some of the specifics about how we did our operation. So, I mean, we created the operation concept, and then whenever we are dispatching out these operations, and I'll show you an example of what one looks like later. We used Avro and JSON in order to do this. Avro is a schema that allows us to validate the format of the values that are coming through. But the two things that I want to focus on here are model and type. Those are two very important concepts here because it's how we allow the consumers, and we'll talk about this later, to look up the right importer in order to pull the data in. And that also includes things like an identifier, which is a key value pair in order to look up the object, a batch ID that it belongs to, and then any attributes that it needs in order to update. So, if you're updating somebody's name, you would send name and then the new name that you want, and then the requester so that we can give people alerts and also audit. Cool. Another primitive, batching. This solely exists as a way to track, manage, and report bulk process operations. Only reason that it exists. Cool. So here's the diagram of what our system looks like in order to facilitate the data team being separated from the application team. And here up at the top, we have, symbolized by Python, the data processes. That's our orange box. We have Kafka as our purple box and our Rails as our green box. So in general, the way that this works is the Python process there, the orange box, is going to produce, it's going to write to a topic. And that topic is going to really just sit there. And then on the Rails side, with the green, they have a consumer, and that consumer is going to read from that same topic. Now, it's also going to do a couple other things. It's going to write to a results topic as it is consuming, and it's also going to reach out to a main controller, which is our red, in order to check and see if it needs to just stop doing what it's doing for a little bit. This is how we prevent disasters from happening. And then our red box down there in the bottom left, this is the only time we'll talk about this, but we have a metadata consumer where we're able to look at both the operations and the results of them and be able to report on the status of these batches that the Python side is writing to the topics. Cool. So let's talk more specifically about the data side. So data producers, that is the orange box. And there are a few things here. They are able, some of the things that are important for the data team to work independently. They have to own their own data stores and be able to work completely independent of anything in the application side. So when the data team is doing processing, a good example of that is the CME and profile example that I talked about, where we are associating citations to real profiles. They have to do that in their own data stores. So they pull the data in, they do any transforms that they need to, and then whenever they are done with what they're doing, they'll run a Python or a Python script or submit a job, and that will write to the Kafka topic that they are targeting. There's also several other ways that we can produce into this. It does not have to be the data team. You can do this from any language, and I'll show you exactly what that looks like here in a second. But you can do this also from a web UI, that red part that I talked about earlier. We also have a web UI that allows you to submit jobs. And then you could also just do this in any like other Rails-based system. So more specifically, this is an example of what a data producer Python script would look like. So up in the top, we have a module that we've created, and this module allows you to create a batch. Notice that with that batch, you just specify a few things. One is like your application target. I chose my app here. That would be the application that is going to be piping this through its rich domain models. Put your username, that is who you are for auditing. And then I mentioned earlier that there was a model and a type. That is right there where it says the job is the model name. that is very important because it tells the system which model that they are targeting. And then last is prioritization. This isn't something that you would need to do in your own implementation of this, but that's something that we've added, and it really helps the data updates go through. So that is wrapping up the batch. Then once you have your batch, you are going to just add some operations to that. Here we are adding an insert, and we are passing some attributes that I mentioned earlier. That is the thing that that represents the update that we are pushing through the system. And then we are adding another operation after that that is doing a separate update with a description. And this Python script can look however you want to. You really just need to build some sort of an abstraction so that your data team can interact with creating or producing data into this topic. But the messages actually end up looking something like this. So after you run the script, it'll produce a bunch of messages that look like this. And this can really look however you want as well. These are just some decisions that we've made. Some things I want to point out here. We have the batch, gives you the ID, and then the size of the batch. In the past, or in the previous slide, we created 2 operations. So this has 2 operations in that batch. We have the index of this update in that batch. We have a type and a type that is an update, and then a model that is the job. So we've given in this operation all of the context that is needed for some process that is using it to be able to read, update, or to find the model that it needs and to update it properly. Cool. So we talked about the data side. Now let's talk about the application side. So the app consumers, that's this Rails part up here. What are some of the things that it needs? First, as part of consumption, you'll need the concept of a dispatcher. So as you are reading from this topic, you will need something that will be able to look at the message that's coming in and find the correct importer for that message. For us, we use model and type. So you tell the model, you say that it's an update, and then we use that to look up the proper class in order to run that through our system. And then for the importer, this is also implement what you need. Some of the things that have been important for us are permitted attributes. So, you know, specifying in advance exactly what is allowed to be updated through the system. You probably don't want admin flags to be toggled here, or maybe you do, but just whatever you're needing for your system. And we also created a like a parent class, abstract class that you can inherit from, and then you implement import whenever you need to do something special in order to send these through our system. And another important idea is whenever we are returning from these results, we return a operation result, like a more of like a value object, as opposed to just like a straight up hash. Now, this is the first example of what an importer is. Your base importer will need to do a few things. Like the first thing, it will need to wrap all of the logic for communicating with Kafka. I omitted that from this because I don't think it's important for this talk, but you'll need to handle things like batch sizes with Kafka, your topic configuration, all of that sort of stuff. But the thing that is important, I think, is this has all of the logic that's related to consuming. So earlier I said it's important to add permitted attributes. Here we add a class attribute that allows you to specify some permitted attributes. We initialize this with some operations and then say, hey, you need to implement the import method so that you can do what you need to do. Then you can also provide some helper methods. Then you can also provide some helper methods like I have there at the bottom, which is like the failed operation result, to make it a little bit easier for people to implement this stuff. And then here's an example of something that is going to inherit from that. This is a basic insert importer. So here, as part of the import method that we have to define, we initialize an array with some results, and then we look at the operations and take the first model and constantize it. Because we've had a dispatcher that's dispatched to this, we're able to look up the model because we know that it's been dispatched properly, and we're only going to be importing based on one model. Then after that, we loop through all of the operations. And then for each operation, you'll define your business logic here. This could be different. For the most part, it's just going to be a lookup by ID. But you find all the operations, and then you slice the permitted attributes and update the object. And at the end, you add the results to that array, return at the end. Once you have those two abstractions, you can build on it in order to really easily implement other importers. Like here's an example of a city importer. So on this, because we've built the importer and the basic insert importer, on this, all we have to do is implement the permitted attributes. And then anybody that's producing it in the system can update a UUID and a name anytime that they want to. And we don't even have to override the import method. We had something more specific that we needed to do whenever this message was coming in. You have the ability to implement the import method itself to override that. But the goal is to not have to do that as much as possible. Cool. So we just talked about some of the specifics related to how we've enabled the data team to be able to work in Python and do all of their data processing, and how we use Kafka to integrate them and separate the concerns between them producing and the application side consuming. And we did it in a way where it is scalable and easy for the data team to use. So when we started, we said, hey, these were the goals that we came up with. Has to work with the existing code base, easy to use by data teams, support multiple apps, safeguards for disaster, bulk processing by default, and independent concerns. I'd say at the end of this, we have really filled the need. And that we've had over 7.7 billion data updates with this system really calls to how much we've leaned onto it in order to provide the ability for our data teams to work independently of the application teams and the application teams to model using Rails all that rich domain logic. Cool. So we just talked about the effective data syncing between Rails microservices. Thank you so much for watching this talk. Just as a summary, we talked about the domain, how Doximity is a physician-first medical network. We have a lot of line of business applications, and our team has grown a lot. And the Kafka-based solution that we arrived at in order to facilitate the application and the data teams to work independently of each other in synchrony. And a couple things I want to point out here. If you like anything that I've said here, go to work at Doximity. Any questions? If you're at RailsConf, I'll be in the effective data syncing between Rails microservices Discord channel. Otherwise, you can ping me on Twitter, Osteo36. And I'd like to give a special thanks out for the slide assistance to our somebody that's on our design team named Hannah. She is the reason that these slides don't look like they were made by a caveman. So thank you all very much for attending the talk. And if you have any questions, please reach out. Thank you.